Hi everyone, in this video we are going to see how to find the length of intercept of a circle on the axis. Let's suppose we have a circle like this whose x-intercept is the chord AB, and let's suppose the coordinates of the point A are x sub 1, 0 and the coordinates of the point B are x sub 2, 0 because both points are on the x-axis, their y coordinate would be 0. And let's suppose the circle also has a y-intercept. It is equal to the length of the chord CD. The coordinates of the point C are assumed to be 0, y sub 1 and the coordinates of point D are assumed to be 0, y sub 2. So CD will be the y-intercept and AB will be the x-intercept, and we have to somehow find out how to calculate the length of each of these intercepts when we are provided with the general equation of a circle. Let's suppose the general equation of this circle is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So first let's talk about the x-intercept, I mean calculating the length of AB. When we talk about x-intercept, you know the y coordinate of both the points on the x-axis would be 0. That means y coordinate of A and y coordinate of B will be 0. So to find the x sub 1 and x sub 2, we need some sort of a quadratic equation. And in fact, if we plug in y equals 0 in the general form of this equation, because both points A and B they lie on the circle, so their y coordinate also will satisfy the equation. So if we plug in y equals 0 in the equation, then we are going to get something like this: x squared plus 0 squared plus 2gx plus 2f times 0 plus c is equal to 0. In place of y, I have used 0 because we are trying to satisfy the equation with the y coordinate 0, and then the quadratic equation that we will get, based on that we are going to find out the values of x sub 1 and x sub 2. So if we simplify this, it looks like x squared plus 2gx plus c equals 0. And that is a nice little quadratic equation, and from here the two roots of this equation would be x sub 1 and x sub 2, and sum of the roots would be negative b over a. In this case, what is b? B is actually 2 times g, a is actually 1. If we imagine this equation to be ax squared plus bx plus c equals 0, so the sum of the roots can be written as negative 2g over 1, which is nothing but negative 2g, and similarly product of the roots can be written as c over 1. 1 is the coefficient of the x squared term, and this is again nothing but positive c. Now what is our task here? We have to calculate the distance between A and B. Because both points lie on the x-axis, the length of the AB chord or the distance between A and B can be written as absolute value of x sub 1 minus x sub 2. In the picture, as you can see, x sub 2 is greater than x sub 1, but again whether x sub 1 is larger than x sub 2 or x sub 2 is larger than x sub 1 does not really matter if you put the absolute value sign. So this will give us the length of the AB chord or the distance between A and B. Now can we write it like this? We can write it as square root of x sub 1 minus x sub 2 whole squared, and then we can write that thing inside the square root. We can write it as x sub 1 plus x sub 2 whole squared minus 4 times x sub 1 x sub 2, because we know that a minus b whole squared can be written as a plus b whole squared minus 4ab. On the right hand side, if you expand it, eventually you will see that that is in fact equal to a minus b whole squared. Now we can plug in the values here. We already know the value of x sub 1 plus x sub 2, and also we know the value of x sub 1 times x sub 2. So let's just plug in the values. So this can be written as square root of negative 2g whole squared minus 4 times c, and that can be written as square root of 4g squared minus 4c, and then if we take 4 as a common factor, we can write it as square root of 4 times g squared minus c, and then if we bring the 4 outside of the square root, that will become 2, so we can write it as 2 times square root of g squared minus c, and that is the x-intercept, that is the length of the AB chord, or that is the distance between A and B when we know the general equation of the circle. Next, we are going to analyze the nature of this circle based on the value of g squared minus c. One possibility could be g squared minus c greater than 0, I mean positive. Another possibility could be g squared minus c is equal to 0. And the third possibility could be g squared minus c is less than 0 or negative. Now when g squared minus c is greater than 0, we can also write it as g squared greater than c, and in that case obviously we will have a real value of the x-intercept. That means the circle cuts the x-axis. So when g squared minus c is greater than 0 or g squared is greater than c, the circle actually cuts the x-axis. Now let's take a look at the second scenario where g squared minus c is equal to 0, or we can say g squared is equal to c. Then what will happen? Well, when g squared minus c is equal to 0, the length of the x-intercept will be equal to 0, because that will be 2 times square root of 0. So that will be 2 times 0, that means 0. So the length of the x-intercept will be 0. That means the circle actually touches the x-axis. The 2 points A and B actually they coincide on each other. So that is when we get an x-intercept length of 0. So in this case we can say that the circle touches the x-axis. And let's look at the third case where g squared minus c is less than 0, or we can say g squared is less than c. In that case we really do not have a real value for the x-intercept, because the quantity inside the square root becomes negative. That means we are talking about an imaginary number. That means we do not have a real value of the x-intercept. That means there is no x-intercept. That means the circle really does not even cut or touch the x-axis. It goes above the x-axis or below the x-axis. It does not touch or cut the x-axis. So we can say the circle is above or below the x-axis. I hope this analysis is clear. Next, let's try to find out the length of the y-intercept. And for y-intercept, for the points C and D, their x coordinates will be 0, because those points are actually on the y-axis. So if we satisfy the general equation with x equals 0, then we are going to get a quadratic equation in terms of y, and from there we can do the exact similar calculations to find out the y-intercept length. So first of all, let's use x equals 0 in our general form of the equation. So we can say 0 squared plus y squared plus 2g times 0 plus 2fy plus c equals 0. All I have done is, in the general form of the equation, I have plugged in 0 in place of x. And if we simplify this, we are going to get y squared plus 2fy plus c equals 0. And this is another nice little quadratic equation. And from here, we'll try to calculate the length of the y-intercept. For this equation, the two roots being y sub 1 and y sub 2, we can say that sum of the roots can be written as negative b over a, that is negative 2f over 1, that is equal to negative 2f. And also we can say the product of the roots can be written as c over 1, that is equal to c. And then what would be the length of the y-intercept? Well, that can be written as the absolute value of y sub 1 minus y sub 2, and that can be written as square root of y sub 1 minus y sub 2 whole square, and that can be written as square root of y sub 1 plus y sub 2 whole square minus 4 times y sub 1 times y sub 2. And now let's plug in the values. We already know the value of y sub 1 plus y sub 2, and also we know the value of y sub 1 times y sub 2. So if we plug in the values, it's going to look like this: square root of negative 2f whole square minus 4 times c. And if we simplify that, it's going to look like square root of 4f squared minus 4c. And if we take 4 as a common factor out, then we can write it like this: square root of 4 times f squared minus c. And if we bring the 4 outside of the square root, that will become 2. So it will be 2 times square root of f squared minus c. And that is the length of the y-intercept of this circle. And again, let's analyze the nature of the circle from the y-intercept perspective. Here again we have three possibilities. F squared minus c can be positive, can be 0, or can be negative. When it is positive, then obviously we will have a real value of the y-intercept. That means the circle cuts the y-axis. When f squared minus c is equal to 0, that means the length of the y-intercept becomes 0, because 2 times square root of 0, that will be 2 times 0, which eventually equals to 0. So when f squared minus c is equal to 0, the length of the y-intercept is 0. That means the circle actually touches the y-axis. It does not cut the y-axis. It just touches the y-axis. And in that case, the points C and D, the two intersecting points, will actually coincide on each other. So the length of the y-intercept becomes 0 and the circle touches the y-axis. And when f squared minus c is negative, then the quantity inside the square root is negative. That means we are talking about an imaginary number. That means there is no real value of the y-intercept. That means the circle neither cuts nor touches the y-axis. That means it could be either on the left hand side or the right hand side of the y-axis. The circle would not touch or cut the y-axis. I hope this analysis also made sense. Next, let's take an example. Let's suppose you have an example like this. It says find the x-intercept and the y-intercept of the circle whose equation is x squared plus y squared minus 4x minus 6y minus 12 equals 0. From the equation we can see that 2g would be equal to negative 4. That means g will be equal to negative 2. And from here we can say g squared will be equal to negative 2 squared, that will be equal to 4. And also we have been provided with the value of c, that is equal to negative 12. So g squared minus c will be equal to 4 minus negative 12, and that can be written as 4 plus 12, which is equal to 16. And here g squared minus c being positive 16 is actually a positive value greater than 0. That means we are going to have a real x-intercept. So let's calculate the length of the x-intercept, and that will be equal to 2 times square root of g squared minus c. So that can be written as 2 times square root of 16, because g squared minus c is equal to 16, and that will be equal to 2 times 4, which is nothing but 8. So x-intercept is equal to 8 unit. Similarly, let's try to calculate the length of y-intercept. From the equation, 2f is equal to negative 6, and from there f will be equal to negative 3, and then f squared will be equal to negative 3 whole squared, which is equal to positive 9. So f squared minus c can be written as 9 minus negative 12, that will be equal to 9 plus 12, which is equal to positive 21. And here again f squared minus c is also positive. That means for this circle we also have a real y-intercept. So let's try to calculate the length of the y-intercept. We know the y-intercept is equal to 2 times square root of f squared minus c. Now here let's plug in the value of f squared minus c. So this can be written as 2 times square root of 21, and that is actually equal to 9.165. So the y-intercept is actually 9.165 unit. And that is the answer for this question. The x-intercept is 8 unit and y-intercept is 9.165 unit. I hope everything made sense. Thank you for watching. See you in the next video.